Now, one part was over, that was the dimensions, then bearing capacity, factor of safety, we got it. Then we have to check the settlement profile. For settlement profile, what are the values has been given, means it is well known. Net load intensity is your 65, not 65, it is coming out to be Q net is equal to 53.92 kilonewton per meter square, B is equal to 3 meter, L is equal to 17 meter. Now, Poisson's ratio mu is equal to given 0.5, IP has been given 2.32, that is your influence factor at the center. You can take it E, modulus of elasticity of clay between 500 to 700 Cu. So, adopt 600 Cu, you can take 500, you can take 700, this is the range. So, with this E is equal to 600 into Cu is your weighted average, this value I am taking it, which is your 25, which is equal to 150 kilonewton per meter square. Now, find it out immediate settlement. So, immediate settlement rho I is equal to Qn into B by E into 1 minus mu square IP. This I have discussed very beginning in the settlement classes, you can recall, you can check. So, this comes out to be Qn into B, Qn is equal to 5392 kilonewton per meter square. So, 53.92 into B is equal to 3, E is equal to 15,000 into 1 minus mu square is equal to 0.75 into IP is equal to 2.32. This is your IP, you can say at the center. Similarly, IP at the corner also given. Based on that, you can find it out what is there, 18 mm. Also multiplying with this, not IP at the center, you can multiply with also IP at corner, then you can find it out, is there any differential settlement or not. If there is an differential settlement, whether it will be within the permissible limit or not. Suppose this is my B, this is my B. So, this will be settlement at the center and this will be at the corner. So, the differentiation, this and this will be a B by 2 and this is your theta, then find it out theta in terms of 1 is to x means something, then check as per BS code whether it is less than your permissible differential settlement or not. So, once it is over, then you go for consolidation settlement, So, in consolidation settlement, check for settlement, first one is your immediate, this part is your immediate, then go for consolidation settlement check. So, at A, where is your A? This is your A. This is your total 3, 3 into 2 6, and this to this is your, this to this your. Now, if I take it, this has been modified into 3 meter, and this total will be modified into 6 meter, and this is your 2 meter, this is your 4 meter. At the middle of the 2 meter, this is A. At the middle of the 4 meter, this is your B. Now, at A, P0 is equal to 19 into 1, 19 into 1, 19 above the water table, 19 into 1 plus 19 minus 10, that is your below the water table is located at 1 meter. Then into 1, why into 1? It is at the middle, this is 2 meter, that means from here to here this will be 1 meter. Now, it comes out to be 28 kilonewton per meter square. Now, you can find it out delta P also, increase in stress, because it is a rectangular loaded area. B is equal to 3 meter, L is equal to your 17 meter, that also you can find it out. Increase in stress also I have discussed. So, delta P, which is equal to 55.2 kilonewton per meter square. Now, find it out at B. At point B, where is your B? This is your B. What is your P0? So, P0 is equal to 19 into 1 plus 19 minus 10, this is your submerged unit weight, this is your gamma saturated minus gamma W into 2.0. Why it is 2.0? Because this soil layer has to be covered. 19 submerged, here you have to find it out submerged unit weight, because water table is at here, that means 19 minus 10, 9 into 2 meter. So, it is your 2 meter plus 8 into 2. How come it is 8 into 2? Gamma is equal to 18. So, gamma submerged is equal to 18 gamma saturated minus your gamma W. Approximately we have taken either gamma W is 9.81 or 10, and it comes out to be 8 kilonewton per meter cube. Then it comes out to be P0, which is equal to 53 kilonewton per meter square. Then similarly, you find it out delta P, increase in stress. First you have calculated increase in stress at point A, increase in stress at point B because of this foundations 17 meter by 3 meter. Here it is delta P is equal to 27.3 kilonewton per meter square. Now you got it, go for your consolidation settlement. Consolidation settlement is Cc by 1 plus E0 H log 10 P0 plus delta P by P0. Cc by 1 plus E0, layer 1 it is 0.06, layer 2 it is 0.15, that is what it is there. So, layer 1 is your 0.04, sorry, it is not 0.06, it is 0.04, I am changing, sorry, typo error. So, it will be 0.04, H is equal to 2, into log 10, then 28 plus 55.2 divided by 28. 28 is your P0, delta P is your 55 plus 0.15 into 4. This is your 4 meter. 0.15 into 4 into log 10, 49 plus 27.3 divided by your 49, then which comes out to be, it is not 49, rather it is 53. This part I am putting it here, it is your P0 is your 53 and here 27.3. So, here it is your 53 plus 27.3 divided by 53. So, it comes out to be 96 mm. You can check yourself doing this calculation, you can check yourself. So, then because this is a clay soil, then you have to apply also pore water pressure corrections. Pore water pressure corrections which is equal to 0.75. So, rho consolidation is equal to 0.75 into 96, which is equal to 72 mm. So, total settlement rho is equal to immediate settlement plus consolidation settlement, which comes out to be 18 plus 72, which is equal to 90 mm, which is greater than 75 mm. It is your permissible. What does it mean? That means whatever you have taken the dimensions, these are not okay for a strip foundations of 3 meter by 17 meter. It is not okay, because the total settlement I am getting 90 mm, which is much higher than your permissible settlement 75 mm. So, what are the options left with you? First option, change the dimensions. If it is not feasible, change the foundation. Change foundation, how you are going to change the foundations? Instead of strip, you have to go for mat or raft foundations. So, first one you try for change in dimensions, check whether it is happening or not, then we will see, then change in foundations, whether if it is change the dimensions are not okay, then we will go for change in foundations. Okay. So, either you change the dimensions, first one you try, this is for your homework, and check whether the settlement criteria has been satisfied or not. If it is satisfied, well good, you can always recommend it, instead of raft foundation I can take a strip foundations here and here, and which will be fine. If it is not satisfied, then you have no other options, because you have tried for isolated footing, strip footing, then you have to go for raft foundations. There is another long problem, so that I am plan to do it in the next class also. So, just in brief what I am going to do it, it is your example 4. Look at the dimensions what is given, I just give a brief outline, then I will stop it because it is not possible, it will take long time here. 1, 2, then 3, 2, 4, 1, 2, 3, 1, 2, 3. This total dimension is your 12 meter, here it is your 16 meter, total load coming in 720 kilonewton, 10 columns, and another column of 10 column, if you look at 1, 2, 3, 4, then 5 rows, so there are 20. So, here it is 720 10 columns, then 560 kilonewton 10 columns. Total is there, and there are also subsoil profiles. So, go for a design. So, here again you have to start with isolated footing. If isolated footing is not satisfied, then go for a strip footing. If it is not satisfied, go for a raft foundations. Basically, this kind of things you will go for raft foundation designs, and this raft foundation designs I will discuss in the next class. Remember, I have not started yet the structural part. Out of the 3 cases, all cases whatever I am doing right now, only soil part, only one example I will pick it, I will give it the how the structural design has to be carried out, and based on that you can do it. You should have also adequate knowledge of structural design, because days has been changed. Once you go for any design firm, you have to do subsoil explorations, you have to report, then you will go for a foundation design. Once you design the foundation, then you go for structural design. Also you have to provide details reinforcements. This example I will discuss in the next class. Thank you.